On into our second lesson of Unit 1. We're going to be taking a look at how to write values in scientific notation. And a big part of this is just going to be proper use of your calculator as well. We'll get down to that here a little later on in the lesson. But just a reminder, for scientific notation, this is the general format that we would see. This guy here, the a value, which is our leading coefficient, the most important thing about him is that it's got to be a number between 1 and 10. So that's what you're seeing right here with this notation. Notice with the equal sign, it can include 1. You could just have 1 as your leading coefficient. But it has to be less than 10, cannot include 10. So 9.9999999 is as high as that could go. So if we're going to take a normal number like this and write it in scientific notation, here's what we got. Just a side note, they also use the phrase standard form to represent scientific notation, so be familiar with the vocab. This is just another IB issue that you have to be aware of. Because this course is IB, International Baccalaureate, they have to use words that translate into all other languages, and so the phrase that we use for scientific notation doesn't translate well into other languages, so that's why they use this often instead of scientific notation. They'll just say standard form. Or they just give you this right here, and they just say write your answer in this form, and they just show the notation. They don't even use words. And so you just got to be familiar with the different ways that you could be asked to do this problem. So anyway, putting our answer into standard form, or also known as scientific notation, if I had a number like 50,700, we know that the decimal given is right here. So in order to get my leading coefficient to be a number between 1 and 10, I would have to move this decimal over 1, 2, 3, 4 places. And so I'm going to put the decimal place right here. That gives me a number between 1 and 10. Because I moved it 4 places, we use the exponent of 4. You'd always have a base of 10. So for this problem here, notice that I kept all of the significant figures. I did not change the value of what I started with. So I do need to include this 507 within my answer. I can't leave off any numbers. Oftentimes people will do that. So be careful. Keep all of your sig figs when you're doing these so that it is exactly the same value as what you started with. We wouldn't round this unless the direction said to. As you get into a number like this, notice the difference between what we did here and what we did over here. Anytime you have a number that's larger than 1, you would always be working with a positive exponent. Anytime you have a number that's smaller than 1, you're going to be working with a negative exponent. And so that's what I wanted you to see, but the difference between A and B here. On this one, again, I have to move my decimal 4 places in order to get a number between 1 and 10. But because this was a number that was smaller than 1, we're going to use a negative exponent instead of the positive. Again, notice I did not change the value of what I started with. I kept all of my sig figs. So that's always important. Going the other direction with it right here. We're going from scientific notation back to just sort of a normal decimal notation. So we're just kind of going the other way with it. So given this in scientific form, because it's negative, I know I should have a number smaller than 1. So because this is a 2, I'm going to move my decimal 2 places. So 1, 2, and we get the 0.035. And again, this is the exact value that I started with. There's no change in value, just a change in notation. And so that's always really important. If the directions were to say something like keep your answer to 3 sig figs, please notice this is not 3 sig figs. This initial 0 next to the decimal doesn't count. So right now I technically have 2 sig figs. If I wanted to make this 3 sig figs, I would have to put a 0 on the end in order to make it 3 sig figs. For this one right here, you got a positive exponent. So again, this is going to be a number larger than 1 because of the positive exponent. With a 4, I'm going to move my decimal over 4 places to the right, and that gives me the 60,000 that you see here. And again, this is an exact answer. I did not change the value of what I started with. This would only count as 1 sig fig. A couple things here that I want you to practice out of the book. So if you're doing this video lesson on your own, we'll be doing these in class together, but if you're looking at the video lesson, if you turn to page 88 in your book, we'll be using some of these for some examples in class, but if you're doing this on your own, please try these. These are cases where you're just using your calculator, but these need to be kind of a slam dunk for points. Oftentimes people do these wrong in their calculator and they get the wrong answer, and you get no credit for these because it's just calculator work. So there's really not a lot of room for partial credit for a few of these cases, and these are really popular test questions. So do try these, but if you go to page 88 in your book, let me show you what that looks like. Here you go. So if we look at a few examples, these are really classic test questions. So they're going to give you some scenarios like this, and then they're going to tell you up above what values those letters represent. And so all we're going to do is sub these values in for the letters, and we're going to put them into our calculator in order to simplify to get our correct answer. So take a look right here. I do want you to try these in your calculator. Again, people really often get these wrong on a test because they just put it into their calculator wrong. So try this. So if I sub in the values for A, B, and C, that's what you're seeing right here. So we replaced A with this number, replaced B with this number, and C with this number. And all this is going to go into my calculator. You just got to make sure that you use the parentheses just like they did in order for this to work out correctly. But do try this in your calculator. Make sure that you can get this answer right. You'll notice in this is a case where you cannot get an exact answer because these decimals go on really far, and so you are going to round this answer to 3 sig figs. So here's what this will look like if we properly do this answer to 3 sig figs. On your calculator, you can actually get your calculator to put answers into scientific notation for you. It's just not necessary. You can do this in your head. You know, as you get this from your calculator, you can write your calculator's answer in scientific notation pretty easily without needing your calculator to do it for you. But if you ever want help with that, I'd be happy to go through it with you. Just come see me and I'll show you how to do your calculator in scientific notation. It's just under the mode button. You can also look at some YouTube videos for things like this. That's how I learned everything on my calculator. So if you're ever interested in making your calculator give you answers in scientific notation, just let me know and I'll go through it with you. But like I said, for the most part, if you just kept your calculator in the normal notation, you'd be able to write this version of the answer on your own just by looking at what's on your calculator screen. So here's what that would look like appropriately to 3 sig figs. Again, just two more here. Again, if you sub in the numbers for A and B, here's the setup that you would have for those guys. And if you throw that into your calculator, again, here's what that would look like accurately to 3 sig figs. Notice that if we just put 3.5, you would be marked off because you would not have 3 sig figs. You need the 0 on the end here to make it 3 sig figs. So here's what that would look like in scientific notation. Here's the biggie. This is a really common test question, and people always get this wrong simply because they do not put the denominator in parentheses. If you're doing this in your calculator, everything that's on bottom of this problem needs to be put in parentheses, otherwise your calculator will not interpret this correctly. So I really want you to give this one a try. Let me show you what that would look like in the calculator if you do this right. So here you go. I just typed that in my calculator, and here's what it would look like. So I did the 3.56 times 10 to the negative 4th on top, and I grouped those in parentheses. You might not have to do that for the numerator, but I do it just to play it safe. So side note, make sure you use the negative button, not the minus sign for this negative right here. That will tell your calculator, probably just give you an error symbol if you do that. So make sure you use the negative button at the bottom of the calculator, not the minus sign. I closed off those parentheses, and then I'm dividing, and so I put everything on bottom in parentheses. So I got the 0.000982 plus 4.56 times 10 to the 6th. And again, notice I grouped the entire denominator in parentheses. That's really important in order to get this right. So now if I hit enter, so here's what we got. What I wanted you to see on this is if you notice your calculator's answer, see the E right there, that is scientific notation. This is the calculator's way of saying times 10 to the this power. So for right here, if we were going to do this accurately to 3 sig figs, I have 7.81 times 10 to the negative 11th power. And so that's what that E represents. It's times 10 to the whatever. And so that's what we're going to get out of our calculator right here. So this number was so large, so small, that your calculator automatically put this in scientific notation for you, even though I didn't change the mode of my calculator. It just did it because the number was so small. We wouldn't have seen anything on the screen otherwise. So anyway, here's what that should look like for us if we do that accurately. Don't use the letter E. Oftentimes students will put a letter E right here because that's what their calculator shows. Don't do that. That's improper notation. Don't use calculator notation. You got to use handwritten notation. So this is what it should look like to get full credit for that answer. All right, going back, finish off the notes here. So we just did those for practice. A couple word problems that you're going to get look like this. And again, as far as formulas go, you really don't have to memorize a bunch of formulas this year. You're going to be given all the necessary formulas within a formula packet that we will make sure we discuss in class, and so you'll have that for every test. But if we're going to find the volume of a cube, and the edges are 12 million centimeters. So each edge is 12 million centimeters. So to find the volume of a cube, you are basically doing length times width times height. That's our volume. But because length, width, and height are all the same when it comes to a cube, we can use this way of writing it as well. So I'm just doing an edge times an edge times an edge. And so we are doing 12 million times 12 million times 12 million. And so here's where we're going to get as far as scientific notation. And that's really the whole purpose of scientific notation, is it's a way of taking a number that is extremely large or extremely small and putting it in relative terms that we can use. We wouldn't want to have to write this one out by hand. That would be a really big number. And so scientific notation just becomes a way of simplifying our process for us a little bit as we write our answers. So again, notice we have 3 sig figs for the leading coefficient, and we have times 10 to the 21st power. So really big number on that. Again, always stick with the accuracy of 3 sig figs when doing problems like this, unless the directions say otherwise. If the directions said, 2 sig figs or 3 decimal places or something like that, then you always go with what the directions say. If the directions don't say, then it's automatic 3 sig figs. So if you look right here, we're going the other way with this problem. What are the edges if the volume is 12 million? Oh, side note on this, because this is centimeters, I should have said centimeters cubed in my answer. Those of you taking the IB test, they want you to use units. So make sure that you do that or they mark you wrong. What are the edges? So in this case, I'm given the volume is 12 million cubic centimeters. And so if I know that the volume is 12 million, then I can now cube root 12 million in order to get one edge. And so if I do the cube root of 12 million, here's what we get in scientific notation. So we got the 3 sig figs for the rounded answer. Again, that's always going to be the case unless the directions say otherwise. One of the things that the directions can say are what we went over in the previous lesson yesterday for lesson 1, and that's that phrase to use an appropriate accuracy level for your answer. And that simply means whatever amount of sig figs they use within the problem, that's how many sig figs you would use within your answer. For this particular problem, in either case, they only use 2 sig figs. And so if this came with the phrase an appropriate level of accuracy, then we would only use 2 sig figs in our answer. But this doesn't have those directions, and so I'm going to automatically use 3 sig figs because the directions aren't telling me differently. And again, same with the case like this. I use 3 sig figs because the directions didn't tell me specifically how to write my answer. Again, on a test, if they want you to write your answer in scientific notation, as I already mentioned, they won't use the phrase scientific notation. They will either use the phrase standard form, or they will just give you symbols, and they'll say, write your answer in the form of a times 10 to the nth power. Something like that. But you'll just give it to you in symbols instead of in words. And so that's something we'll get used to as we go throughout the year. So a couple formulas that you needed for the assignment for this particular lesson are given to you right here. So you might want to take note of those. Again, like I said, most things that you'll need for tests are going to be in a formula packet. And I would always warn you if there was anything you needed to memorize. So last side note right here. If the problem does come with the phrase appropriate level of accuracy, and there are two different forms of sig figs within the problem, like let's just say they gave you a value with 2 sig figs and then another value within the same problem of 3 sig figs, well, which one do I go with? Which one is more appropriate? And the answer to that is you always use the lesser amount. So if I had a problem where one value was 2 sig figs and the other value was 3 sig figs, and the direction said use an appropriate level of accuracy, I would go with the one that had 2 sig figs because it's less accurate, it's less specific, but that's the one I would have to go with.